Good evening, students. Am I audible?
Yes, sir.
Okay, and what about the my screen? Is it visible?
Yes, sir.
Okay, thank you. So in the last class, we were discussing about the OSI layer and till transport layer we discussed, right? Then there was three remaining layers: presentation, session, and then application layers. So in that tool, it was difficult to write all the information. So I better made a few slides. So in this slide, I'll make a little bit more interactive, uh, so that you will get a more idea about the OSI model layers. Then I will take up the TCP model and the uh, networking devices, little bit one or two networking devices information I will give. Fine. So we have seen in the OSI model layers, we were I have mentioned like 7 layers are there. So the applications, presentation, session, transport, network, and the data link, and the lowest layer, what we call is the physical layers. And I had mentioned that the topmost 3 layers, that is the application, presentation, session layers, are called the software layers or the upper layers. And the heart of the OSI model is the transport layer, right? And the remaining layers, that is network layer, data link layer, and physical layers. These three are the lower layers, and these 3 layers again we will call as a hardware layer, because these three network, data link, and physical layers are available in the hardware devices, like networking devices. For example, hub, repeater, right, switch, router. So in these devices, these 3 layers will be there. So that's the reason we call the hardware layers. Okay, this is the actually how it looks. So this is the sender, right? This is the sender, and the B is the receiver guy. Suppose, and this is the router 1 and the router 2. So we call the intermediate nodes or the routers, whatever it is. If it is in the same network, so these routers would be there. Maybe we can say at that time the hub or the repeater, right? So there's a sender, for example, the your laptop or the mobile phone or the device A. So in the laptop, mobile phone, all the 7 layers are will be there, right? And similarly at the destination side, all the 7 layers will be there. So intermediary node or the routers will be having only 3 layers, because here software part won't be there, only the hardware part will be there, right? One is the physical links, right? The second one is the network interface card, right? And the third one is the router, right? So these for transmitting from one network to another network, so we need the router. So that's the reason only the 3 layers are there in the intermediary nodes. So the seventh one, so the application layer 7. So here the application layer directly interfaced with the user, right? So whatever you see right now in your mobile phone or in your laptop, so this is like interfaced with the user. So whatever I write or whatever you write, you can easily see, or whatever you search, you can easily see, correct? So in order to whatever I write in my laptop, so and whatever I see in my laptop, for this we need a certain protocols, correct? And these protocols are defined in the application layers. For example, the X.500 is one of the protocol. So what it does is it will handle the message services. So that's why this we call the message handling service protocols, right? And we are having a file transfer message protocols also, right? And the application layer, whatever the data is there, for example x.500, okay, so this is the directory access control protocol. So whatever the information is there, it will put in the message format, right? And this message format will be sent to the next layer that we call the presentation layer. Okay, so this is like in the sender side or the originator. So come to the receiver side. So whatever the work or whatever the function it has done at the sender, so those function will be done here in the reverse direction, right? So here the whatever the extra 400, so message handling service protocol, and that message is sent to the presentation layer, then it will goes to the session layer, then transport layer, network layer, right? And data link layer, finally physical layer. From the physical layer it will go to the intermediary nodes, for example router 1, then the router 2, then it comes to the destination. From the destination again it will come from the bottom to up: physical, data link, network, transport, right? What is the session layer, then comes to the presentation layer, right? Then from the presentation layer it will goes to the concerned port, right? Extract 400. Then this user, the receiver, can able to see whatever the sender has sent the message, right? So the main service or the main function of this is to provide the networking services to all the users, right? And this also we call the desktop layer, correct? And the identification of the services. So in the previous slides, right, this x.500, ftams, x.400, these are the protocols for a particular service or the particular function, right? So how to identify these services? So the identification is done using the port addressing. So this is the port address is a 2-byte address. So its length is the 2 bytes, 16 bits. So this is ports are nothing but sockets, right? So this is the one application, right? And this application, so this will be there in the application layer, correct? And to enter into this application, so we have a one door. Okay, this is the one door. So this door will be called as the socket, right? So in order to identify this socket, I'll be using the number called the port number, right? So for entering or exiting, we will be using this socket or the ports, right? For individual services, the unique port numbers should be assigned. For example, so the as I said, the port numbers, the total length is the 2 bytes, right? So total number of ports is 2 raised to 16, correct? So it will come around 65,536, right? 65,535 or 36, right? Ports will be there. So in that we are having some reserved ports, for example mail, right? Or for the DNS or for the HTTP, right? So we get right port number 80, so that is for the HTTP, right? So these are all the standard things. So they have already reserved some ports, so that ranges between 10 to 1023, and some of the open ports are there. For example, you have developed one application app, right? And for that app also we need to have a one kind of a port, right? And that port will be taken between 1024 to 65,535. Okay. So let's see how the data flows from the application layer. So this is the one service. So before this, yeah. So these are the services, HTTP, right? The port number reserved. So these are the reserved port numbers, 80. For the file transfer protocol, we are having the port number 21. And for mail, this is for the Gmail, whatever the mail or VAT mail, Gmail, Yahoo Mail, whatever we do, we use, right? So that is the SMTP protocol based. So it uses 25 as the port number, and the telnet, it uses 23, and the TFT. So this is also one of the file transfer protocol. So it uses the 69, right? So let's see in the how exactly it will look in the in our system, right? In terms of the layer wise. So the application layer is there. So in order to, so suppose I am creating the one HTTP, so HTTP dot, right? Some email, some address you will be writing URL. So that is like 80. So for that it will be created a one entry or the exit gate. This we call the socket, right? And similarly for the file transfer protocol, email, right? Or this is for the DNS, right? And this is for some other one of other application. This is for the file transfer protocol, right? Then this will be given to the presentation layer, right? So in the presentation layer, what it happens? So whatever the application layer has given the message to the presentation layer, so it will be put in its own format, right? Its main role is to encoding, encrypting, and compressing the image, right? And after doing all these functions, it will put a small header here, H6, right? And it will gives to the next layer called the session layer. So again, this is the sender and this is the receiver. So whatever the function we have done in the sender side, so those functions will be done in the reverse way at the receiver side. Let's see in detail. So one of the main responsibility of the presentation layer is to converting the data into standard format, right? So I want one particular format, right? Or the mobile phone, right? My mobile phone and the my laptop, right? So suppose I'm sending some file to my mobile phone, and that format will be opened in my format, and those both the format, both the protocols, right, will be the same, right? But the presentation of the presentation of the content will be different in the laptop and in the mobile phone. So that format will be changed whenever the presentation is there. For example, the converting ASIC to ASIC to the some other language like EBC, DIC, or I want to convert from the one format of the image to the another. For example, JPEG to MPEG, right? Or .aps to .png. So these all tasks will be done here. So the main three tasks are there. One is encoding and decoding, right? And the encryption and the decryption, then compression and the decompression. So these all will be done at the sender side, and these all will be done at the receiver, or both, and or both, right? Both will be done at the receiver or the sender. So depending upon the where I am sending those informations, so what kind of device it is, so depending on that device, the encoding, right, or compression technique will be changed. So the next one is whatever the presentation layer has done, so that data will be sent to the session layer. And session layer, again it will put its own header, and that data will be sent to the transport layer. Then transport layer receives the data from the network layer. Then that data will be sent to the session layer. So again, this is the sender and the receiver, correct? So we will see how the session layer works. So has the name, it says that session, right? The new connection, right? Session is a one new connection. So initiating that connection, right, or establishing that connection or maintaining that connections, right, and terminating that session between two communicating devices. So all these function will be defined in the session layer, right? And the major duties of the session layer is the synchronizations. Suppose you are having the very huge file, correct? And that huge file cannot be transferred at a one time. Right? So we have to be, segment that one. And at the end, again, we have to connect all the segmentation, whatever we have done, we have to reassemble it, right? So for that, the particular format will be there, or particular procedures will be defined in the synchronizations, right? And the second one is the dialog control, right? So here it determines the role to be played at any given time by a host. For example, duplex. So two ways simultaneously communicating, whatever we usually have a communication over the phone, right? So that is the duplex. So at a time both can exchange the information, no need to wait. But in the half duplex, what happens is I'll speak, then I'll wait, then you will speak, then I'll wait, like walkie talkie, right? And in the simplex, it's a one way, like for example, the radio, right? So radio, whatever the news or whatever the functions or whatever the session is going on in the radio, so that is a one way, whatever they say, just we need to listen it, we cannot tell them anything, correct? So that is the simplex way of communicating at the dialog control. And the session layer protocols are the SQL, right, and the Apple talk sessions control, or RPC, that is the remote procedures call. So yeah, once the all the work is done at the session layer, right, and it will gives to the transport layer. So in the transport layer, see whatever the message I was having in the session layer, L5 is divided into three different types, right? I'll come to why, how it is done, or why it is done, right? So here we call the segmentation. Maybe depending upon the type of the application, right, or depending upon the MSS, maximum segment sequence, correct, it is divided, and these divided, each of the segment will be having the header information H4, right, and it will be sent to the network layer. So this is the sender, and at the receiver, so whatever the information we have sent here, right, so those information will be here, and again we need to do the reassembling of them, right? So this is the reassembling. Fine. So the main role, or the one of the important function of the transport layer is to provide the end-to-end connectivity, right? So whatever the system we are having A, right, and the B, so if they want to communicate with each other, so this is the, here the process is running, and here also process is running, and that process we identified as the port address or the socket, right? So in order to provide, or in order to communicate both each other, so we need the transport layer, right? And we know that this is the heart of OSI layers, and main services here is the identifying the services. What kind of services you want? Do you want the connection oriented services, or you want the connection services, and multiplexing and the demultiplexings, and the segmentation which I have told you, and the sequencing and the reassembling. So many whatever the messages I have received from the session layer, right, so I'll be segmenting, correct, and each segmentation will be sent through the network layer to the data link layer and the physical layer, and at the receiver layer, at the receiver side, again it will come to physical data link and network. Again I need to reassemble, in which order I need to reassemble, right? So for that I need a numbering to the what we call the segment, right? So that will be achieved in the sequencing. So I'll come to with an example. And the flow control, and the error control, right? So at what rate the data has to be sent from the sender to the receiver, right? So that how to come to a conclusion. Once the receiver knows what is its receiving rate, and that information if he communicates to the sender, then only the sender can put on control, right? So depending on that information, he can send the data, right? And the error corrections, right? If any errors due to the environment or the noise, right? Or the third party who wants to corrupt the data, right? So how to correct it, how to detect and the correct the errors. So that those kind of responsibility will be taken by the transport layers, right? So I have mentioned like it will provide the services, right? So two types of services. One is the connection and the one is the connectionless services I told. So this is like a connection oriented service. Transmission control protocol provides the connection oriented services, and user datagram protocol provides the connectionless services. And TCP uses the three-way handshaking, right? 3W, three-way handshaking, and it will doesn't have any handshaking. No three-way handshaking here, right? And if any data is lost in the TCP, so the acknowledgement will be sent, or if the data is successfully received, also acknowledgement will be coming. So actually acknowledgement here we are having positive acknowledgement and negative acknowledgement. If positive acknowledgement comes, is the successful. Negative acknowledgement comes when there is a packet or the segment has not reached. So then again retransmission is done here, but here no acknowledgement at all. If you are using the transport layer protocol as the UDP, then whatever the data we are sending, we are not bothering about next whether it has reached or not reached, or corrupted, or error packet has received to the destination. That is not a responsible, right? So that's the reason they call the unreliable service is the UDP, and the reliable service is the TCP, because if any data is corrupted, again retransmission is done, the same segment retransmission is done. That's why we call the reliable. So that's the reason there is a slow process here, but here it's a fast. So whatever the data is that just we will be sending. So port number used for the TCP is the 6, and the UDP it is a 17. And these are the different services the TCP will provide: HTTP, file transfer protocol, or your mails. And this is the domain name, or if you want to assign some kind of IP address, right? So dedicated host configuration protocol, or the file trivial file transfer protocol will be done using this UDP. So I said that like multiplexing and demultiplexing is the one of the services. So means, so whatever the reliable services are there, right? So all the reliable services are mixed, or combined into a one segment, right? So this we call the multiplexing, right? So we call the multiplexing. So this way it is a multiplexing, right? Top to down, and bottom to up we call the demux. So this is the multiplexing. So this is multiplexing, and the bottom to up is the demultiplexing, right? So we will be dividing the each services, and we will be sending to the respective ports. The segmentation, so here I have taken the example. Suppose the A is the sender and B is the receiver, and the sender wants to send a message like hello, how are you, right? So how it will be done? So this is the complete message which has come from the application layer, correct? Which has come from the application layer. So in the transport layer, what will happen? It will segment, it will divide into segments. So here, right, 5 segments, and all the 5 segments will be sent to the B, right? So this process we call the segmentation. Fine. Good. So the third one is the sequencing and the reassembling. So whatever the message we wanted to send to the destination B, right? So what we did, we have segmented and we have transmitted, right? So in this way we are receiving. So as we are using the packet switching, we are not using the circuit switching, so the order of the segments will be the not in order, it is in order, right? It's not in the particular order. So suppose I have received in this format, so what we will read, you, hello, how, and question mark, or. So it's not a meaningful, correct? So in order to make a meaningful, so we need to reassemble in a proper way, right? So for that we need a sequencing. So what we will do, so whatever the segment we will do, we are assigning a one sequence number, 1 by 5, 2 by 5, 3 by 5, and we will be sending to the B. So at the B, what we are receiving in the same, in the different order we are receiving. So first is you, hello, how, right, question mark, and or. So later the reassembling is done. So this will be the first, right? Then hello, how are you, and question mark, right? So this we call the reassembling with using the sequence number. Good. So we can read easily, hello, how are you, right? So the fourth one is the error correction. So how to correct the error? So same example we will take, and we are sending the messages. So here there is a loss, right? Right. So here there is a loss of packet. So as a result, what we will read here, so there is a segment missing, so we cannot read properly this, right? So for that what happens, as we are using the TCP layer as a underlying protocol at the transport layer, so just what it has sent is one negative acknowledgement, right? So that negative acknowledgement, it will be responding what negative acknowledgement has come according to the sequence number. So that segment only has sent by the A. So as a result, we will get the whatever the missing segment was. So how was the missing segment, right? So this segment will be added here. So this is how the error correction will be done at the receiver side. And finally, we will get whatever the sender was sent the information. Hello, how are you? And the flow control window, right? So yeah, here what it says, sending 3 window, right? So 3 messages or the segment will be sent. So received 3 window, and we are receiving 3 messages back. Those are the acknowledgements, and it says that acknowledgement received 3 and the sending window is 5. So it increased the sending window. So now 5 segments will be reached here, but the receiving rate is only the 4. Only 4 has received, so 1 has lost, right? And 4 has received, so all the 4, the positive acknowledgement has sent it back. So it's understood that the sender, okay, the receiver has sent only the 4 acknowledgement, means it can receive at the max only 4 segments. So after that it will send only the 4 segments at a time to the destination B. So this is how the transport layers works, and its different functions. And then in the network layer, so whatever the data, So in the network layer, it's a in the transport layer, right? The messages or the data we'll call the segment, correct? And in the application layer, presentation layer, and the session layer, the data is called as a just message. Okay. So in the network layer, so whatever the data has sent or the segment, so this is a segment. So these are the segments. Segment has that is sent to the network layer, and whatever that data is there, that data complete, and the network layer puts its own header, and this they will call the packet, right? So here data is called as the packet, and in the transport layer it called as the segment, and the upper three layers or the software layers it called as just a message, and it puts the header, and those header along with header so will be called as the packet, and that packet will be sent to the data link layer, and at the this is done at the sender, right? And the reverse function will be done at the receiver. So whatever the data the data link layer has sent, right? So here the header will be removed, right? Only the actual data will be sent to the transport layer, right? Let's see the actual functions. So network layer is known for providing the optimal path or the best path or the shortest path in order to reach from source to the destinations. So source and the destination. So many routes will be there, right? So like this many routes will be there. So which route is the suitable route in order to send the packet so that it will reach that desired destination within a time or the very less time. So that's the main function of the network layer, right? So in the network layer, so one of the function is logical addressing, right? So logical addressing, or what we call the IP addressing, right? And this network layer sits in the router, right? So network layer will be there only in the router, not in any other devices, right? It won't be there in the switch, it won't be there in the bridge, it won't be there in the hub or the repeaters. So this logical addressing, right? So whatever the we are having the IP, yeah, okay. Here actually network layer has the two different protocols. One is the routed protocols, for example IP, IPX, apple talk, and the routing protocols in order to get the shortest path, right? So that is the routing information protocol, or IGRP, or open shortest path uh, protocols. So all this will be there in the routing protocols. So how the data flows from the network layer, or from the application layer to the network layer, and from the network layer to the data link layer. So in the application layer, whatever the message was there, that is the data. So the presentation layer, it will put in the proper format, or it will convert into a particular format. Then it will start the initiation of the connection between the source and the destination. Then segmentation is done here, and here there is a actually here we will add the one header here segment, so they have not shown. So next segment will be sent to the network layer. So in the network layer, the whatever the segment, so here whatever it is there, no, so this includes everything, this much. So whatever the segment, the six segment will be here, and along with that segments there is a addition of the network header, right? So this is the IP, right? This will be the IP. So that we call the packet, right? Segment plus network header right? Network header is the IP address, source IP and the destination IP, and this complete information or the data will be called as the IP packet, and this will be available in the router, right? For example, you can see here, so on the packet I want to send it from the A, right, to P. So actually this is the P, this is not R, this is P, so R is here. So I want to send to the P, right? Right. So what it does, it will, so you think as A has the, so all the letters, capital letters are the physical address or MAC address, right? And these 10, 87, so these all numbers are the IP address, correct? So here, for example, this is like, you can say that this is the one segment, or the no, these are the like bits, zeros are one, zeros are one, like this. Then after that, here it's a, data packet, so which has the physical address, MAC address. So this is the source MAC address, and this is the destination MAC address, and this is the IP address of the source, and this is the IP address of the destination. So A wants to send some information to the P, right, and each of them has the IP addresses 10 and 20. So it will be routed through this way, right? So it will reach here. So that's the here. So this is like a source address and IP, I mean destination address, physical address. These are the MAC address, MAC, and these are the IP address. So the network layer will provide the information. So the complete, this is the packet, right, and this packet will be sent to the next layer, so that we call the data link layer, right? So in this data link layer, whatever the packet is there, this is the packet, right? So I'll write PKT. So this is the packet, and along with the packet I'm adding two more headers. One is the header and another one is the trailer, right? And this complete one I'm calling as the frame, right? And this frame will be converted into the zeros and ones, and that will be sent to the physical layer. So these all functions will be done at the sender side, and the reverse, like from the converting the zeros and ones into the frames, then frame again it will be sent back to the packet at the network layer, right? So this reverse function is done at the receiver. Right? So here, say you can see the, see whatever we had here, right? So this is like a frame, right? So the actual data. So in this data, what is there? This is actually the packet which has come from the data link layer, I mean sorry, network layer, right? So for this I'm adding a one trailer and on the header. So header has the source MAC address and the destination MAC address. Okay. So in the data link layer, as I have already discussed in the previous class, it has the two sublayers. One is the logical link layer, and the second is the media access control layers. Right. So this is for the mainly used for the error controlling, right? And this is used for the media access control. It is mainly used for the accessing the link, whether it is busy or the idle. If it is idle, then send. If it is a busy, wait for some time. So for this I have a the addressing, so they call the physical address, and it's a 48 bit of size, okay, 48 bits. So one of the responsibility of this data link layer is error detection, and this data link layer working device on which is the switch, bridge or network interface code, which you might have seen in your desktop, right? So the data link layer, so main responsibility is moving the frames from one hop to the next, right? Which I have, with a diagram I have explained in the previous class, right? So the one of the major duties is the framing. So the data link layer divides the stream of bits from the network layer into manageable data units. So again, it is depending upon the MT, maximum transfer unit, depending on that. So certain amount of bits will be put in a one format, right? So that format I will be calling as a frame. And the second one is the physical addressing, right? MAC addressing. So in order to distinguish two different, two different devices in a distributed system, we will be using the MAC address to identify, right? And this is the MAC address usually in general in practically whatever the NIC will be there, right? Network interface card, right? So for this NIC, the address is the physical address. So for every NIC, suppose your desktop or your laptop is there, your laptop is inbuilt. So if your desktop is there, where you will be putting the Ethernet for the network accessing, right? Uh, so you'll be putting in a port, right? So that port is the actually the network interface card port. And if you remove that port and if you use the one more network interface card, then we will get the different physical address, right? And its format will be like in the hexadecimal format. And again here also we will be having the flow control, so rate at which the data has to be sent from the sender to the receiver. So both rate is same, receiving and the sending rate, then there will be no collision. And if there is any difference between the sender and the receiver, if the receiver rate is less, then it's always lesser than the sender, then always it's a problem. But if it is in the reverse direction, if the receiving rate is more and the sending rate is less, it's fine, no issue, but wastage of the bandwidth. And here also we will be having the function called the error control, right? So these all mechanisms we'll be studying in the data link layer. And access control, so some of the functions which we have seen in the transport layer, so some of them also we will be using in the data link layer. So here it will be within the network, within the one particular network. And suppose if you want to have a from between the networks, so there the transport layer will come into picture, right? And how the data flows from the data link layer uh, is like this. So till session it's a data, then segment, then packet. So here comes the packet, right? Whatever the network information is there. So the complete one will be, this packet complete will be placed in this small packet. And we will be having the two headers like now, header and the trailer, and this I am calling as a frame, and this will be available in the switches. So the final one is the physical. So this main responsibility is to responsible is for the electrical, mechanical or procedural checks. And here actually data will be converted in the binary, right? Zeros and ones in the physical. And data will be in the form of electrical pulses if it is coaxial or the discrete pair cable, and in the form of light if it is a fiber optic cable. And devices working at the physical layer is hubs, repeaters, cables and the modems, which we have seen in the last class. And this is how actually looks in the physical layer. So in the physical layer we are whatever the data we are the this we call the frames, right? So the frames will be again will be formatting into the zeros and ones. and these zeros and ones we will be putting in the either digital wave or the analog signal, and that we will be sending through a media, right, either coaxial cable or fiber optics or twisted pair cable. Then we will be sending to the receiver, right, and again we will be sending to the data link layer. So again this we call the frames. So finally it looks like this. So we are having data, segment, packet, frame, and finally we are having the bits, right, and it's in the hub. So whatever we have studied in the previous lab, right, hub we have seen. So in the hub only the physical layers will be there, so transmission of the bits. So in general, what we can say is the topmost layer, application layer, it provides the network process to the applications, and presentation puts in a proper format, or it will, we can represent the data in a proper way. And session, like interhost communication, establishing or disconnecting, so those all functions will be done in the session. And transport layer, it provides the end-to-end connection in order to transfer the data. And the network, it provides the IP addressing or best route to reach the destination. And data link is accessing the medium, right, whether it's a busy or idle, when to access it, so that there should not be any collision in the network. And finally the physical layer, that is a actual binary transmission will be happening in the physical layer. So this is the complete uh, OSI reference model. So data encapsulation means whatever we have seen just now, and in reverse way. So this is at the sender and receivers. So whatever the function is done at the sender, the reverse of that will be carried out at the receiver. So let's see here. So data is there, data, and it will come the data with the header. So we call the segment, and the segment with the network header is the packet, and packet with the headers are the call we call the frames, and frame is the bits, and these bits will be flowing through the physical medium, and it will receive at the receiver. So again it will convert the signals into bits, and those bits will be converted back into the frames. And here, so we were having the two addresses, or the uh, uh, and those addresses will be removed. We will converting back into the packet, and that packet will be sent to the network layer, and the network layer again it will remove its IP address, and it is called as the just segment, and the segment is sent to the transport layer, and transport layer, so again here the header will be removed, so this will be called as the data. Then the data will be sent to the session, presentation, then application. So will be put in the proper format, and we'll present to the sender, where we are seeing in our screen, right? So this is the application layer. So we have seen the OSI layers. So let's see the TCP IP layers, how the TCP IP layers. So we were having the 7 different layers in the OSI, and in the TCP IP layers we are having the 5 layers. How 5? So whatever the 3 layers are what we call the software layers, application, presentation, session. So all this will be merged, and they have made into one layer called the application layer. So this is the 5th. And the transport layer, as it is same, the 4th, and network are also same, 2nd, and the last one is the physical layer. So 5 layers will be made. And actual implementation, whatever we are having in our laptop or mobile phone or wherever the communicating devices are there, only the TCP IP layers model is there. OSI model is just for the references. So using this reference, they have derived this TCP IP, because the certain functions are similar here. So that's the reason they have combined the session, presentation, and the application layer, and they have made it a only one layer called the application. application layer, and remaining layers are the same. So that's all I wanted to discuss, and actually I wanted to introduce the networking devices, but we don't have time right now. So anybody has any queries related to the today's class?